Good day, everyone, and welcome to today's DevOps.com webinar. We're excited to have you join us. Our topic today is securing the cloud, top down and bottom up. Our webinar is being sponsored by NetSPI and DisruptOps. I'm Mitch Ashley, and I'll serve as your host and moderator. Just a few housekeeping items. We are recording the webinar, and all participants will receive an email with a link to the recording as well as the slides. Also, we're giving away two $50 gift cards, Amazon gift cards at the end, so stick around and find out if you're a winner. I also want to mention that our speakers love questions. Both great people as well as very conversational. So please enter your questions into the questions tab on the GoToWebinar software, and we'll love to answer those here during the webinar. So let's move on to our topic, securing the cloud, top down and bottom up. It's my great pleasure to introduce our two fantastic speakers. First will be Karl Fosaaen, who is Practice Director at NetSPI, followed by Mike Rothman, President of DisruptOps. With that, I'm gonna hand it over to you, Karl. Take it away.
All right. And Mike, if you want to go to our intro slide here.
Introductions. I guess it's time for introductions. All right, let's do it, Karl. Let's do it.
All right. So as mentioned previously, I'm Karl Fosaaen, a practice director here at NetSPI. Joined the company back in 2011, so I've been with the company about 8.5 years now and worn a number of different hats, everything from pen tester to manager to now leading up our cloud pen testing service out of our Portland office. I've also created a tool set based out of PowerShell for pen testing Azure services called Microburst. You can find that out on the NetSPI GitHub, but I do a lot of pen testing in the cloud, primarily around Azure. A little bit more about NetSPI. We were founded back in 2001. We work with a number of top financial institutions, do a lot of work in the cloud. I myself spend pretty much all my time working in the cloud, so either AWS, Azure, Google, you name it, there's a cloud provider, I'm typically doing my work there. So in addition to that, we do a number of engagements every year and report a ton of vulnerabilities. So I'm here from a pen test perspective to talk about securing the cloud from the top down.
Top down, I guess that means I am bottom up. So I'm Mike Rothman, President of DisruptOps. Some of you, especially in DevOps.com land, may recognize me. I also am president of a research firm called Securosis. And again, been a 25+ year security professional, done a whole bunch of different things, but I always seem to get back to pontificating, waving my hands, and trying to say somewhat entertaining things as kind of what my general skill set is. So a little bit about DisruptOps. We were founded in 2014, really started up operations in 2017. We were the 2019 Innovation Sandbox participant at the RSA conference, so that was a lot of fun and really exciting. And really what we'll talk about today is this idea of trying to address a number of the issues that Karl and his ilk, the folks that break into your stuff, actually how you fix that on a systematic basis, right? So it's not just about, kind of hitting on, one vulnerability or one exploit and fixing that, but really building a cloud security program and really a scalable, consistent cloud security operations environment that allow you to handle all the things that are going to get found. And, as we know, these guys are real good, so they find stuff. What we want to do is deal with it consistently, again, accurately, and make sure that you don't interrupt operations on your cloud security environment in any way, shape, or form. So that's DisruptOps. We'll go through our stuff a little bit later on. So Karl, you ready? Ready to go through? All right, let's do it. Cool.
All right, so securing the cloud from the top down. So from my perspective, I typically view cloud environments as a potential pen test target. So be it the applications that are being hosted in the cloud, the networks that are being hosted in the cloud, or any of the sensitive information that may be residing in the cloud. And with our clients, we've seen a noted increase in cloud adoption over the last 5 to 10 years. Everybody seems to be moving things to the cloud, and it seems to be accelerating day after day. It seems every potential client scoping call that I'm on nowadays, the cloud's involved somehow. So from an application pen testing perspective, you may have some pretty kind of standard app pen testing requirements as part of your application development process. And what we're seeing from a cloud perspective is a lot of these legacy applications are now being ported up into cloud environments. This opens up a pretty wide variety of potential vulnerabilities just based off of the cloud infrastructure that's being used. In addition to that, lots of new applications are being built cloud native, and there's a lot of security concerns that might not necessarily be taken into context as these new applications are being built up. So that's where pen testers come in to try and find where these gaps may be taking place.
Karl, do you see a kind of X% new versus Y%, kind of lift and shift? I mean, do you have, kind of a gut feel on what that looks like?
It really depends on the client. So a lot of our more established, larger companies are really porting a lot of their applications over to these cloud environments versus some newer, I guess newer companies are really building new applications as more cloud native applications. And it seems to be, I would argue, probably a 70-30 split between more legacy type development versus just cloud or fully cloud development.
Do you get excited about one versus the other? Is it like, ooh, this is new, I get to go break some new stuff? Or is it like, oh, this is going to be easy because it's old crap that they haven't refactored to go into the cloud at all?
I think equally on both, because a lot of times we'll see problems from 10 years ago come up in the infrastructure as a service side of things, where it's shared local admin everywhere and there's credentials in clear text on all of the servers. So it's easy for us to start pivoting and moving around. But whenever there's something new, introduced at reInvent, it's like, oh, well, it's a new AWS service. We can, let's start hammering on that.
Yeah, cool, good.
So definitely get excited about that. In addition to that, every time any new code pushes come up or new developments, we got to go back and pen test those applications as they're being deployed, as there may be new issues that pop up from an application standpoint. One thing I'd like people to keep in mind is it's not just web applications that are involved in the cloud. Lots of mobile applications have APIs that are hosted out in the cloud, along with thick client applications. We're seeing lots of issues with thick clients. And as things develop more into the cloud, a lot of the endpoints that these thick client applications, standard executables on the Windows system, the endpoints that these clients will reach out to are more frequently now being hosted out in the cloud and bring along some security issues with that. Along with that, we do network testing as part of our standard suite of services here at NetSPI. And over the years, as things migrate into the cloud, we've had more exposure to external IP addresses being hosted out in the cloud, internal infrastructure being hosted out in the cloud, and I guess more recently, environments where PCI or the cardholder data environment is being moved into a cloud environment to help with segmentation. It ends up being kind of an interesting switch, as it's typically a wholly isolated environment just by design as part of the PCI standards, and testing segmentation between those cloud networks and how that bleeds over into standard Active Directory environments, or how that integrates with a cloud environment, has made for kind of interesting test cases for PCI.
Yeah, I bet. And it's kind of interesting from that perspective, because when you think about the architecture of the cloud and how the services work, you really should be able to isolate it in a decent fashion. Yet, I can't tell you how many times we run into environments where they've decided to go with a flat network because it was easier, right? Or they're trying to save a shekel or two to try to, oh, the NAT gateway was expensive, so we just basically put everything on a common subnet, and peered across VPCs, and then we walk right up to the wall and bang our head against it, kind of 50 times and go, okay, let's take a step back and think about what architecture should be. And then you have the whole multi-tenancy thing. I mean, I imagine you do a bunch of work with SaaS providers, right? And then you have multi-tenancy, like, well, what does data isolation mean to you? And they're like, oh, well, we do that in role-based access control, and then you go bang your head against a little bit more, because like, so if I bust your app, I can pretty much see all the data. Well, yeah, okay. That's not multi-tenancy in my world. Right.
It becomes one service account that can read everything. Yep. Very common. We run into that quite frequently.
Yeah, so. I bet.
So yeah, in terms of pen testing the cloud and kind of taking that more traditional approach that we just kind of talked about and extending that out to the cloud, we really recommend people take a look at both the network and app pen testing, as we've done in the past, but also adding in cloud configuration review and really understanding that deeper dive of how those services are being configured and being used. So, we put with the top item here, how do we pen test the cloud? Well, with permission first. And one of those permissions that we typically ask for is some type of read access for those configurations with that cloud provider. So if we're in an Azure environment, we want to be able to read all of those policies for the Azure Active Directory users and how those policies are being applied, with IAM. Likewise with AWS users and accounts there, how those IAM policies are being applied across those different services. And then how that kind of applies from a network and app testing standpoint. As we talk like multi-tenancy type situations, if you've got a single AWS service account that has access to all of the client data in an S3 bucket, how are you really separating all of that client data from tenant to tenant that's being served up in that AWS environment? So really taking those configurations and diving deeper on those in conjunction with your network and app pen testing is going to give you a deeper view into those networks and applications that are being hosted up in that cloud environment.
So it's not really a blind pen test, or you'll do that too, just kind of like what the adversary will do. But I mean, obviously, if you're getting access to some of the configurations and you're looking at a level deeper than you would hope your adversaries have.
Yeah,
Not always
definitely.
clear, right? Sometimes if they've jackpotted your environment, they can pretty much, kind of do whatever they want. But yeah.
Exactly. And, from our perspective, we're testing externally as kind of an anonymous, but kind of more of a white box. We can see the configuration to see what's exposed. And from the internal side of things, we'll typically test from an EC2 instance or a virtual machine to see what that internal network looks like, because much like corporate networks, you may have a solid exterior, but the interior is very soft and easy to move around from system to system there. Number of environments that we've been in where all of the web applications that manage the underlying infrastructure are set with admin and password for their management credentials is extremely common. So yeah, one of those things you want to look out for. And when we talk about isolation, making sure that things are properly isolated. So if one of those EC2 instances is compromised, how do you prevent somebody from moving from one system to another or getting access through those web management consoles? So to kind of answer your question a little bit more, yes, we do treat it as more of a white box type assessment where we've got full understanding of the environment. However, we do try to make sure that we kind of isolate those scenarios that could be potentially exploited by a completely anonymous attacker.
Yeah, right. And I think it's both, right? And part of what we'll talk about later on, not to, steal thunder, is, continuously looking at a lot of those configurations to make sure that nobody from an operational change perspective does something to endanger or add, attack surface to your environment.
Exactly. And those work hand in hand. So from a services that we care about perspective, from a configuration review and kind of pen testing perspective, virtual machines, infrastructure as a service, that's one of the key things that we're seeing issues with. As I previously mentioned, issues from 10 years ago are just coming back up with these cloud environments. Shared local administrator credentials, excessive permissions for local administrator rights on virtual machines, wide open flat networks where if one of these virtual machines or EC2 instances is compromised, it's really easy to move around from system to system to system, and jackpot. Exactly. So we care about how those services are configured and making sure that everything's set up properly there. Serverless code is another big thing. We're seeing lots of clear text credentials being hard coded into Lambda functions or Azure Logic or automation accounts, anything like that. So serverless code is something that we're definitely diving deeper into and really care about how that code's being executed and run. So is your Lambda code actually running with administrator access policies and has access to everything? So if somebody can modify that serverless code,
are you restricting network
like
access to, kind of what the Lambda can actually influence and connect to?
Exactly. And we see the same problems across, all of the different cloud providers from a serverless code perspective. From a platform users and groups, so Azure, you're looking at Azure Active Directory, AWS, you're looking at AWS accounts or potentially federated accounts. We want to see how those permissions are applied across the different services. As kind of previously mentioned before, can users get specific access to services that they shouldn't get access to? A recent example of this, we had a client who's making use of Azure container registries to store all of their Docker images. And in these Docker images, they have some secrets for accessing services. That in itself is kind of an issue, but these container images being stored up in Azure actually had an IAM policy applied so that all domain users, as in the all users group in the domain, had reader level access on the registry. So anybody in the environment could actually connect to Azure, pull down that image and see those credentials. So not the most common configuration issue we run into, but definitely one of those instances where these IAM permissions can be really extended, even accidentally. But Mike,
I was just saying, let me, kind of, one, repeat after me, kids at home. Secrets management is your friend, right? Vault, key man, AWS, kind of what's they call it, secrets manager,
Yep.
and Azure's Key Vault. Those are actually pretty important services to make sure that you don't do that. We had our own little issue with that, with some code that went up to GitHub about 8 years ago. So we were early in that, kind of thing, but you only have to teach us once, right? And you realize that that's really a bad thing to do. But what I wanted to, kind of ask Carlos, since we're seeing a lot of this stuff that's 10 years old, right? Is it because we have folks that are really developers or ops folks that are doing things in the cloud and trying to secure them? Is it because the security folks just forgot what it was that they learned in SANS class, 15 years ago? I mean, how do you put local administrator to all servers that you run up in your cloud? I mean, how does that happen?
So a lot of it comes from templating. So you build a single gold image and that's got a shared local administrator, and you build all of your virtual machines out of that. That's probably the most common issue that we've run into with sharing that local administrator credential. Is you deploy out this gold image template and that gold image just keeps that same local administrator credential. But I think the real source of it is security probably hasn't fully caught up to development in terms of agility and getting into these cloud environments, because we'll see with a lot of our clients that they'll have an AWS or Azure presence that they didn't realize. Oh, we've been connected to Azure for 5 years, we've had a subscription, but security never knew about it because development got ahead of themselves, wanted to move things to the cloud, and security is catching up 4 or 5 years later and finding some of these issues.
Development decided technology and security was getting in their way, so they just did it.
Yep. You end up with the shadow IT.
That's right. Yeah. We get involved in a lot of those things. We're like, oh, hey, can we see what policies you have from the IT group? They're like, no. Well, nope. Why not? They're like, because we don't talk to them. Oh, don't ask, right? And then you get the look, don't ask. Well, it used to be a look. Now it's just over the Zoom. You have to interpret that now, yep. or the webcast, you have to interpret that. But yeah, they've gone around IT. They've gone around security. And obviously you have things like this that happen when, kind of you don't have somebody sitting there, at least giving them a sense of what secure is. Right? What does it look like? No, we don't want to get in their way, but you got to at least give them a sense of what it looks like. We call that guidance, right? Guidance is important to give to these folks.
Yep, for sure. So kind of speaking of that shadow IT and having Azure integrations that people didn't know about, one of the important things that we look at is integration with those identity providers. We do frequently find misconfigurations where things like all users are assigned to an AWS account or Azure subscription. And when you start looking at the larger picture of exposing IDP or federation endpoints out to the internet and all of the public breach data or people just choosing weaker default passwords, it's easy for us as an attacker standpoint to guess somebody's, let's see, we're in spring 2020, so we're typically guessing capital S for spring 2020 as somebody's password. For any attendees that are using that, you may want to avoid using season year in the future. But we'll guess that against an external facing IDP and then get access to one of these cloud providers as part of our external network pen test. So you pair those things together with excessive permissions in those cloud environments, all of a sudden we guess somebody's weaker default password, and then we have full access into that cloud environment. So definitely something to look out for. It's definitely something that we're looking for as pen testers. And kind of last thing in terms of services that we really care about from a pen test perspective in a cloud environment is potentially public-facing platform as a service services. So things like web applications or databases that might get exposed out to the internet, or everybody's favorite, data storage. I think the most public breaches that everybody's probably very well aware of by now, S3 bucket out open in the world and it's got client data, sensitive information there. How do we lock that down and prevent attackers from getting access to that? So from our perspective, we're taking a look at any of those potentially public-facing services and trying to make sure that you're not exposing something that you shouldn't. All right, so you may be asking at this point, okay, well, we're a little afraid of potential security issues in our cloud environment. How would we go about scoping or planning for a cloud pen test? From the base level, I would say include your application and network layer on your next application or external network pen test, potentially internal network if you're making use of internal resources for that, or ExpressRoute, VPN connections, anything like that. But from our perspective, identifying what that scope is for your cloud environment, really gathering those counts of resources in your environment. So this would be virtual machines, public IP addresses, platform as a service. How many RDS databases are you making use of? How many EC2 instances? How many Lambda functions? Really taking stock of what that asset count or resource count is in your environment, really getting a better understanding of what that overall exposure is. We do see a number of clients that end up with kind of cloud sprawl, and they end up spinning 18 different Lambda functions when one of them is really the only production one. It kind of helps give you a stock of that as well, but also gives you a good idea of what to scope and plan for a pen test.
Yeah, and the thing with cloud is it's much easier to enumerate what you have as long as you know what the accounts are, right? If somebody has a different account that's out of your purview and you don't pay for it, it's not part of your organization or tenant, that becomes difficult. But you actually can just ask, right? The console, what's here, and they actually tell you. I mean, and all other things failing, you get a bill. Because if there's one thing that the cloud providers are actually really good at, it's charging you for stuff, right? So if it's on the bill, it's in use. So you can, again, as a path of, kind of last resort or a means of last resort, if you just can't figure out everything that's there, the bill will tell you.
And, ironically, my Azure bill just went through today and saw the notification pop up for my credit card.
Turn some stuff off.
Thankfully, I closed everything down. This was a test environment that we spun up.
Even when you kind of actually take things out and delete stuff, sometimes you leave a VPN or VNet up in Azure land, or and again, you would think that there's things that when you take an instance down or you really remove a stack, that these things would get removed as well, and not so much. So you figure it out when you get your bill.
I was a little bit ahead of it. This was something that we spun up as a test environment and forgot to delete the virtual machine disks. I deleted the virtual machines, but the disks still persisted, and those cost me an extra $5-10. But thankfully, not too
$20 for you this month.
Yep.
Gotta pay the $10.
Exactly. And so you made a very good point with being able to pull all that information out of the console. I think one of my favorite features in the Azure portal is going to the All Resources tab, and you can export everything to a CSV. It makes it super easy to do asset inventory. From a pen tester's perspective, we actually export that CSV, kind of carve it up to individual services and use that as part of our tracking. So make sure that we hit the virtual machines, storage accounts, pretty much everything that's in that asset inventory as part of our process.
Right, which gives you much better coverage, right? So if you're doing a blind test, then, statistically you're getting X amount, but it's not 100%, right? Obviously, if you have everything enumerated, you can go in and, really, beat on pretty much everything and get a much better view of what the true exposures are, as opposed to, when you're in an on-prem, just
exactly,
to, stumble through it.
Well, and that's a really good point, especially if you're looking at, trying to do a full cloud assessment versus just including external IP ranges for an external pen test. From our external pen test perspective, we're going to try and enumerate any S3 buckets or public AWS services that you're going to be making use of. But if you're naming your AWS bucket, 20 characters long and something that we're not going to guess as part of our enumeration tactics, but that bucket's wide open to the internet, you may have an actual exposure there that we're just not going to see without some type of read-only access into that environment.
Yep.
So yeah, I think that kind of covers it for the planning and scoping. Really just making sure that you're including those assets as part of your pen test process. As everybody's moving more and more to the cloud, make sure that security is keeping up with that as well.
So let me just ask you another question before I kind of dive into my stuff, Karl, because I'm fascinated by this. When you're doing kind of repeat engagements, right? So obviously people come in and say, hey, do this, every 6 months, every year. Do folks fix the things that you actually find, or is it just like Groundhog Day? You come in, it's like the same damn thing. Oh, it's a new same damn thing, right? Every same damn thing. You've got a template of the report, and you just literally cut and paste it because or duplicate the file because it's the same stuff all the time.
Yeah, I would actually say that people are better with their cloud environments versus their internal applications and networks. We have some clients where we've gone back year after year for internal pen tests and see the exact same problems year after year. And we've had some cloud environments where before the end of the cloud pen test, we've seen pretty major sweeping changes to fix all of the issues as we've been reporting them.
Yeah.
So I'd say from a validation perspective and actual remediation, from a cloud perspective, people are a bit more agile. I think some of these environments are a little bit less complicated and easier to remediate some of these issues as well. So
Yeah,
we're
but
seeing,
by definition, right? I mean, if we're
oh yeah,
using modern development stuff, we should be looking in terms of microservices and kind of just the way, even in an orchestrated container type environment, I mean, you should be able to fix things, replace things, kind of update things, hopefully in a much faster way.
oh yeah. Yeah, and from my perspective, it's actually really refreshing to see these things get fixed very quickly. It can be a little disappointing when you call something out a year before and then come back to that same
Yeah,
network or application. Go, oh man, they didn't fix that. That one's a
yeah,
bad one.
yeah.
Yeah.
Yeah, and that's one of the and one of the reasons certainly on our research kind of side of the house, the idea of providing the guidance that these folks need, because and that's really kind of why I asked the question, is because what we've seen is developers, ops people, all the folks within kind of these cloud teams are not averse to making security changes, right? They're not going out there saying, hey, I really want to open up all this data so that half my customer database ends up in Eastern Europe or South America or kind of the Middle East or in Nigeria, right? Nobody gets up in the morning and says that, right? It's just that they don't know what they're doing most of the time.
Yep.
So if we take the time as security folks and actually educate them in terms of what both the expectations are and what the best practices should be, and really how to leverage a lot of the clear capabilities of the cloud, you're just in a much better spot, right? I mean, and because these folks want to do the right thing. It's just
Oh
nobody's
yeah.
told them what it is,
Yeah.
which really is a good segue, right? Because Karl and his band of merry people are going to show up and they're going to find stuff, right? They're going to find stuff doing the anonymous things. They're going to find stuff, because you're enumerating your entire cloud for them, and they're going to look for things that are misconfigured, and all of that is good, right? All of that is good, but you're still in a very tactical type of situation, right? You're just in an environment, hey, give me a list of stuff to fix, I'll fix it, move on to the next stuff to fix, I'll fix it, right? And that is a difficult place to be. You never make progress. You're always in that firefighting mode. And that's a challenge. I mean, listen, I've been doing this for, 25 years, right? And I kind of, used to discuss it and talk about it as you get up in the morning and you put your fire extinguisher on, right? You go to work and you see what's burning the hottest. You go over there and try to fix it, right? Try to put the fire out. And then by the time you're done with that, there's another fire, sparking up somewhere. And then if you didn't do it right the first time, the embers are starting to, ignite again. And it just becomes this, again, Groundhog Day type thing, right? Every day is the same, never make progress. And it's a problem. And this, I always try to start with a little bit of humor, here, right? I don't always, that's the most interesting man in the world who does not bear any resemblance to me. I did not do that intentionally, not at all. What's funny is that usually we don't do the video on these things. So I would have worn my, tuxedo jacket if I knew just to do it that way. But I don't always fix pen test findings. Okay, I never do. I suck at SecOps, right? And, that's kind of a joke that we tell up front. One, to set the stage, but two, to really, help folks understand that it's not you, right? Everybody has a hard time doing this kind of stuff at scale, right? When you start thinking about it, again, we've got some clients that have, hundreds, sometimes have thousands of different cloud accounts, right? You can't stay on top of all of that. And one by one, I mean, Karl loves to hear about stuff like that, right? Because that's, 1,000 accounts I can go, kind of break and play with. Wow, this is going to take me a while, right? And he sees the cash register moving, and that's great, right? And that's why, great company and good friends of mine, and that's, you know, fantastic. But the reality is, when you get to that kind of scale, you really have to start rethinking a lot of your operational motions. You can't just do what you've always done, right? You can't get to a point. I remember Heartbleed. Carl, remember Heartbleed, right?
Oh
You know,
yeah.
yeah, Heartbleed. So, you know, big infrastructure level challenge. Every server on the cloud, really on the internet, but certainly within every cloud, had to be dealt with. It was a fundamental aspect, part of the stack. You know, you really had to go and change every single machine, right? You can't do that. I mean, I'm old enough to remember a thing called SneakerNet. Right, that's when you actually took a floppy disk
Yep.
and went out to every. Oh, you're not that old, Carl. Come on. Mitch is that old, right? You're not that old. You know,
I've had
you
the
remember
sneaker
SneakerNet?
net. Yeah,
Yeah,
I
well,
you,
I've
resemble
I've
that
had to
remark,
with
by the
I had to with USB drives during
yeah, all
configure.
right, USB
So
drives. Okay, that's great. I'm talking good old fashioned floppy, and that was, you know,
yep.
that was the joke. We used to say, you know, oh, SneakerNet. Like, how long would it take? And how long would it take to, you know, go with the floppy to every one of those hundreds of millions of devices out there to fix them for Heartbleed? An infinite amount of time, right? So that's not happening. You've got to figure out, and you've got to really rethink what SecOps is. And this is another, you know, exacerbation, right? We call it the security hamster wheel of pain, right? Which is, for the most part, you spend a lot of your life just, you know, and again, not to be facetious about it, but, you know, kind of ignorance, right? Yeah, I'm just doing my thing, you know, and then you get an alert, or you get a notification, or worst case, the Secret Service calls you and says, sir, you have a problem. Well, what's the problem? I can't tell you that. It's part of an open investigation, right? And oh crap, right? That's the am I hosed? You know, so then you do a couple of scans. Maybe you know, contract with Karl and some of his folks to figure out what it is. So they run some tools against your environment, and basically like, yep, you're kind of screwed here. You're hosed. I've got the thing to prove it. You know, we've got all these vulnerabilities. You've got, you know, local admin on all these different servers. I've got no isolation because to save, you know, 10 cents a month, I decided to put everything within a common subnet. I mean, we hear it all, right? And the the universal aspect of that is, ultimately you end up panicking and fixing, right? Triage is the key thing. And Karl, you know, I love to hear, you know, when you say you're going through a pen test, that you go through these things and folks actually are fixing things as they're doing it, right? They're fixing the problems. They're going through a triage. They're going, holy crap. That's so we were doing an assessment actually early on with the DisruptOps tool. We did, you know, basically the assessment of the customer's environments. We found a couple of overly privileged IAM rights, or roles, in the environment, and the customer said, oh, hold on a second, right? And he gets off the phone. We're onboarding him onto the system. Right? He said, hold on, you know, and he goes and he fixes it. Okay, now it's fixed. It's all great. Said, well, that's fine, but if you would have just hit this button, you could have actually fixed it right there,
Yep.
right? Because that's what our tool does, right? It's like, oh, okay, right? But this guy was so fired up about the fact that, oh crap, I got, you know, overly excessive privileges on my IAM. I got to go fix it right now, right?
Yeah.
So and again, that's kind of the mentality that we want, which is not just sitting here and, you know, ignorance is bliss, not on the hamster wheel of pain, or, you know, the fire extinguisher every day, but to think more strategically about security operations, and understanding the reality that things are a lot more complicated now. Things are happening a lot faster. We've got servers that live for 10 minutes. Right, we've got stacks that can come up, they come down, and all of this adds to what is a constantly expanding and contracting attack surface. So you never really know what's going on in your environment because it changes so quickly, right? Speed of change, DevOps, DevSecOps, right? Agile approaches, infrastructure as code. Right? You know, it really doesn't take long to set stuff up in your environment. In the good old days, right, you'd have to order the server and it would get shipped to the dock, and you'd have to go down to the dock and get it, and you'd have to find rack space, not the company rack space, right? Space in your rack. Right, you have to space in your rack in order to do things, right? And then you had to provision the server and like load it up with the gold image. Oh crap, where's my disk with the gold image? You got to go upstairs to get the gold image to come down and do that. Right now, clickety click click, right? And in right, you've set it up in about 10 seconds. And if it's infrastructure as code, you don't even have to do that, right? The script automatically does that. The stack is set up, the servers are initiated, they're running. It happens outside of anything that you can do at a speed that, again, is very difficult to keep up with, certainly at scale, right? Human error. We're all humans. Humans, you know, and they're very good at many things. Security operations consistently, accurately over time, not so much, right? So we're always going to run into those human error things. And by the way, sometimes, and by human error, I'll say sometimes it's a mistake. Other times it's just to facilitate what they're doing, right? They want to do it faster. The credentials that are in the container images, that example that you talked about before, that's just because, well, it was easier to do it that way.
Yeah.
Right? It's a pain in the ass to put, an API into to hit on the secrets manager into my, I'm just playing around with this stuff until you're not, right? Because that's how everything, it's a prototype, and then that code magically ends up in a production application with your credentials in there. What could possibly go wrong, in that kind of environment, right?
I think that's where most of those problems end up coming from. Well, it works on my side, so yeah.
And that's exactly right. And that's, and that's the huge problem in doing this, especially the more DevOps teams you have, the more agile, it's like, oh, before I started my career on a 200-person project team, right? You'd never see that now, right? Now you got groups of 3 or 4 max, right? And they're doing that, but you've got a whole bunch of them doing different things, and they're also, really enforcing that level of practice continues to be a challenge as well. And then finally, your automated attackers. So joked about that before. Hey, there's no way I'm enumerating that, randomly called bucket in your environment, but somebody is. And why? Well, because they test. I mean, literally, they scan everything. Everything on the internet is scanned multiple times per day. If it's out there, they are going to find it, right? It may not be this second, but it's probably not an hour from now either, right? And you can do the test, right? Just put up something,
Yeah.
call it something random, make it vulnerable. It is owned within 10 minutes, without a doubt, without fail. Within 10 minutes, the thing is owned. So it's hard, right? Scale is hard. Pen testers are finding stuff. My ops team, is making changes all the time. I'm spinning up new stuff in the cloud because it's so easy to do that. It's hard, right? So what do we have to do? We've got to think about it again from a different perspective. We want to take a different perspective in terms of what cloud SecOps looks like moving forward. So it's a lot of the same stuff we've been talking about, right? So we've got our events, we've got an API, we've got our different cloud environments. But what we really want to do is be able to really scale up our capability to perform these security operations motions, just like our cloud does, right? If we need a lot of it, we have a lot of it. If we don't need that much of it, we can contract it down so that we're not paying for what it is that we don't need. We've got a couple of different use cases. We'll go through, 2 of them later on, but the idea is we've got, kind of a governance. That's my assessment piece of it, right? Don't focus that much on it. There are dozens, if not hundreds, of tools that can tell you exactly what's going on in your cloud environment. The remediation and the detection and response thing gets a lot harder, right? Because that's actually fixing stuff. And, I don't call it, does anybody get up in the morning that you talk to that says, God, I wish I had more alerts when they wake up?
No,
No,
nobody.
right? Said by nobody ever, right? And we kind of make that joke because it's not about alerts. It's not even about better alerts, right? It's about doing stuff. And it's about taking those actions, taking what my findings are, understanding where my issues are, and actually fixing those issues where I can, and letting the humans do what the humans do well, which is coming up with cool architecture to take advantage of the unique capabilities of the cloud, right? It's finding out which controls are going to work where. It's determining what your policy should look like, and then giving you the ability to enforce those policies across, your entire cloud consistently, accurately, redundantly, scalably, all of those things that you really want to see in your environment. That's what a security operations platform can do for you. So what do you want it to be? Well, you want it to be serverless, not so Karl can come in and break it, right, and find out how we're, invoking all these different things, but because of that scalability, because what you want to do is be able to spin up enough of these actions where you need to, but you don't want the thing running all the time, right? That just doesn't make sense. You want it to be event driven. What does that mean? It means I have an issue that could happen because I've done a scan or an assessment on it, or it could happen because I've gotten an attack, right? We'll talk about this in a second, right? But I could get an AWS guard duty or a security center alert based upon their machine learning that says, this looks kind of funky, you should really look into it. And with that, what I do is then go through and take actions. We want the event to drive action. We want it to be SaaS. We don't want to build it ourselves. And ultimately, you want it to be secure, because what we have to do is provide access, or we have to get access to your environment in order to make these changes. You want to have a sense that these folks know what they're doing, they understand what security is. The idea of least privilege isn't, something that you inflict upon your kids, right? You get the least privilege, kind of there because you weren't good, you didn't do your homework in online school, you get least privileges tonight. No, we're talking about least privilege, like, you don't give excessive privileges to anybody, right? Least privilege from that standpoint. So those are the things you want to see in a security or a cloud security operations platform. Let's just kind of take it for a test spin, right? So here's a little example of an open admin port, right? Port 22, open to the internet. That's basically SSH. What bad could possibly happen if you have SSH open to the internet? Well, depending on how long your password is, that there's directly correlated to how soon your server will be busted, right? Because they're going to brute force that thing every single time. So what we want to do is make sure that that doesn't happen. We determine, basically we're constantly looking at a number of different rules, right? Open admin ports would be one of them. We see that that's an issue. The action is to restrict it, not just take it offline, right? Because then that stops the ability for organizations to work. What we want to do is lock that server down to a set of known IP addresses that we know come from a legit place. Maybe it's your VPN, maybe it's a certain set of, IP addresses that you use to manage these systems. Whatever it is, you don't want to take the system totally offline. What you want to do is make sure that it's managed in a safe environment, and then verify the resource or verify the action, refresh the resource and inventory to get back to that point that Karl made, that sometimes we find these findings and they don't fix it, right? So this automatically fixes it, and then you make sure that you have notified or that you've verified the fact that you have actually fixed that environment. So that's, basically that's a guardrail, right? A best practice. There are dozens of, CIS has what, 60 or 70 of them that, kind of they recommend for both Azure and AWS. Those are things that you can set best practices for, not only in our tool, kind of you can build all these things yourself, by the way. You don't need us to do a lot of these things. It's just a lot harder and will make you crazy over time, but that notwithstanding that. So let's say you actually get some kind of attack, right? This is actually something that happened to us. Again, it was 8 years ago because my partner uploaded our access key into our, GitHub repository. Again, what bad could happen then? Well, I'll tell you exactly what bad could happen then. Somebody busted into our accounts, spun up a whole mess of Litecoin miners in our account, cost us a bunch of money that then AWS refunded. Thank you, AWS. We'll send them a shout out from that standpoint. Didn't cost us a couple $1,000 on that front. But back then we didn't have guard duty, right? There was no guard duty to actually look at my account and go, why all of a sudden have you set up, 15 extra large instances to do something when you've used like 3 smalls for 3 years? So that's the kind of stuff that you're getting out of guard duty. That gives you the alert. What happens when you, get that alert from guard duty? You say, oh crap, the alert that says we have, potential cryptocurrency mining happening. What do we do? Right? So then we actually have an automated motion that you can, enforce, or a run book that you can play to, basically ask whether you want to shut stuff down, right? We'll talk about that in a second. So what we've done is we've gotten humans involved there because automation can be scary to a lot of organizations. But basically the point is we want to terminate the instance, right? Crypto miner is happening in my account. We want to terminate that instance. So let's go do that with the run book, obviously making sure that it's not something that's authorized, making sure that you've got the proper controls over it, making sure that you are restoring access to your root account to make sure that that doesn't happen again. So there's a whole bunch of stuff that happens with this specific run book, but the idea is it's triggered by a guard duty alert, right? In the first one, it was triggered by an assessment finding on that front. But what you want to do is have an issue, have it trigger, have action that happens beyond that, and then provide, again, verification that those changes were made with notifications and reporting. And verification is actually a pretty interesting concept because, again, automation is scary to a lot of folks. I've been doing network stuff, I mentioned, like 25 plus years in security. I started as a networking person. And I was scared of automation. I mean, I'll tell you, it's funny. I work for an automation company now, but I was scared, right? Because you always heard the stories of some automation running awry and taking down half your network, and it was a huge problem, and you never wanted to be in that situation. And we understand that, right? So what we did is we basically built, for lack of a better term, a chatbot. right? We integrate with Slack. That's what is shown here. We have Microsoft Teams support as well. And basically we show you, here's the alert we got. Here are the actions you can take. Is that cool? Or you can delay them, right? Well, I don't want it. I want to look into it. Give me 15 minutes to do that, or give me an hour to do that. So you can delay the action as well. But what we've done is we've gotten humans involved, right? And that's important because that gives you the comfort for what the machines are doing in your environment, which again is one of the constraints that we've seen towards widespread cloud-based automation. I mean, listen, the DevOps people have no problem, if it passes the test, send it out, through test and then, out to production, because they're controlling the test. They know exactly, what's in there. The odds, they're looking at the templates, the odds that they're going to do something totally wacky is small, and then they can roll it back anyway. Operational automation, people trend into that much more slowly, and the decisions technology, the chatbots, the ability to have the humans involved in the process really will facilitate folks' comfort with automation. So that's really where, kind of again, top down meets bottoms up. We identify the issue, whether it is, again, Karl and his team doing stuff, whether it's your typical scanners, whether it's, AWS or Azure or GCP throwing an alert at you through their machine learning. You have an issue, you triage that issue, right? And that's usually where a lot of folks who have started around with automation get to. They've remediated it once, and then they've decided, or actually in reality, they've remediated it probably a dozen times, and they're pissed off about that, right? So they build a Lambda or an Azure function to do that automatically, right? So then they're in the automation business. And the problem with that is then it's code, right? It's code you got to support. Got enough code to support, so you don't want to support the automation code, right? So then you want to get to a point of continuous assessment, automatic and automated remediations and actions on that front to, again, make sure that whenever Karl and his team find stuff, you've got a security operations platform and environment that allow you to fix that consistently, reliably, accurately every single time.
Well, and then with those alerts and notification, you can then feed that back to the team that's creating that infrastructure, and then future build cycles, you're ending up building that securely up front.
You bet. Yeah, and that's actually a great point, because we do hear that a lot. They're like, why would I have you make an operational change when I'm just going to redeploy my entire stack once it kind of flows through, and I have, basically have to make the same operational change again. And they have a point. The fact is, depending on how long you are between deploys, if you deploy every 10 minutes, you're probably okay, although statistically maybe not. If you deploy 3 times a day, I can guarantee you, depending on the operational issue you have, you're going to have a problem, right? Maybe you blow it away and your problem doesn't persist. Maybe you're lucky, maybe your stuff is in Chechnya by then, right? So our point is, it's not a matter of either or. Closing that loop is exactly right from the perspective of, wanting to understand what those operational challenges are and then have that map back into the template, so that, again, you're not just in Groundhog Day. Not that we have a problem making the same change over and over again. We're cool with that, right? But, it's not optimal, right? It's not efficient. Yep. So Mitchell, where's my friend Mitchell? He went away for a little while.
I'm here for you. I would never abandon you.
Back. No, don't, please don't. I'm delicate. I'm like a snowflake. You can't be doing that.
Just a wallflower. I know.
Yeah, that's right.
I did love your meme, by the way.
Good. Yeah. You can steal that one. That's a good one.
That's awesome. Yeah, it's really good. First question is kind of goes back to something that you were talking about, Karl, about how fixes tend to happen more quickly in the cloud than in private data centers environments. What are some of the reasons for that? And are there any lessons there that we might take back to our private corporate environments, data centers, networks?
I'd say that they probably get fixed faster due to the agility of kind of cloud deployments and cloud environments. Typically smaller environments, less dependencies on other systems. When you look at legacy applications that are hosted in a data center and have lots of dependencies between databases, firewall rules, other things that kind of tie back to these traditional data center type architectures, you have multiple different teams that you have to work with typically in those types of situations. So if we find a SQL injection that allows us to get access to a database, they may have to deal with the database team, an application team, and potentially a firewall team in order to remediate that issue. If all of those team members are part of the cloud team and it's a relatively small cloud environment, you may have 2 people versus 15 people that you have to talk to remediate those issues.
So kind of integrating your teams together in the cloud can also bring benefit to your private corporate environment then. Interesting.
Yeah, definitely.
Mike, any perspective on that yourself?
Yeah, I mean, I think a lot of it was what we had discussed, kind of during the, during the session, right? It's just that you've got folks who are motivated to have a functional, high-performing cloud app that works, right? And they viewed, and they're software guys, right? So and gals, right? So they see defects as what they are, defects, and defects are something that we want to fix aggressively, quickly. If they consider that, kind of a tier one type of defect, they are going to move, heaven and earth to fix that stuff as quickly as possible, which again is shocking because one, security people tend to have one low self-esteem, right? But besides that, they're not used to folks actually being responsive to the things that they're asking them to do. So it really is kind of shocking, when folks have already fixed that. It was no joke when we were doing that first assessment for one of our very early beta customers, and kind of we pinpointed this kind of excessively privileged account, and the guy literally said, "Hold on a second," dropped off the call and fixed it right then. It was just like, hold on, mate. We wanted to, we were going to show you how to do that, right, with the tool. You didn't. It's like, oh, sorry. It was an important thing. I didn't want to wait. Just like, oh, well, who are you, right? I mean, most folks, that never happens in security. So it really is, on one hand, refreshing. On the other hand, as security folks, we got to bring our game, right? Because one, false positive, no bueno. Because these guys are going to drop stuff, right, in order to do stuff, which means they're not building functionality, they're not improving performance, they're not optimizing stuff if they're, not fixing your false positives. So when the alerts fire, they better be good alerts. And again, that's part of why the triage aspect is important, but kind of bringing it back to close the loop and really automate a lot of those things that you have to do over and over again. Again, folks get real bored doing the same thing over and over again. So automation is your friend.
Mm-hmm. Absolutely. The next question is talking about the difference between corporate environments and cloud environments. In cloud, it's much easier to have the virtual network to test in, as well as your compute and storage. Oftentimes in an enterprise network, that's not the case. It's production network, and yeah, you might have a test environment, but it doesn't really emulate your production network. Any suggestions on ways you can kind of mitigate those differences so you are, as you deploy, both in, I guess, in a hybrid environment, that you're secure and that from the network side of it?
That's a good question. From a cloud perspective, it is a lot easier to manage those networks and those exposures. From an internal perspective, if you're lucky enough to have an actual dev UAT environment that you can push to first, making sure that that environment most closely mimics your actual public exposure or prod environment is usually what we recommend. If we're testing a prod environment or a non-prod environment that is nothing like the prod environment, what kind of value are you really getting out of that test?
Mm-hmm. That's a good point. Next question is, just share what you find are the most common configuration issues in cloud environments leading to security issues from both your perspectives. Mike, maybe you want to go first on this one. I know you and Rich, your partner, have talked about this previously.
Yes, yeah. So we see a bunch of stuff, and honestly, for a lot of folks that don't have a huge amount of experience in cloud, we recommend that you, as I'm fixing my slide that didn't have the right stuff in there. And I kind of mentioned it before, right? We do point folks towards the CIS benchmarks as kind of a way to, kind of set down a standard platform or standard set of controls that you can implement in that environment. So when you start to see things, right, it's kind of like PCI, right? If you can't defend against all the requirements in PCI, you're going to have a long day in the office, right? Because that's where everybody starts. That's the first thing that they do. Or Metasploit would be another one, right? If you can't block all the stuff that's given, that you can just download from the internet and defend against those attacks, man, you're going to have problems, right? So CIS in Cloudland, CIS is kind of the gold standard of kind of how folks should be configuring their environment. So you start there, right? You look for those kind of things. And by the way, the good news is every vuln-ish thing in the cloud worth its weight actually has that built into their tool, right? AWS Security Hub, right? Microsoft Security Center, they all have that as a base thing. They look at your environment, they can find those findings against it. Then the real question is, what do you do when you get that, kind of report that says, oh crap, you haven't set these passwords correctly, you don't have MFA set up on these things, you've got these open admin ports, as the example I ran in through before. So we say, start with CIS. Once you get there, then there are a set of best practices that you can get from a lot of other different places. But if you can't even kind of meet those standards, again, you're gonna have a long day in the office.
Mm-hmm.
Yeah.
Karl, anything you want to add?
I think from more kind of technical and service related perspectives, we typically see issues with data storage. So things like S3 or storage accounts being publicly exposed. Everybody's very well aware of those breaches. Those are commonly misconfigured IAM permissions for any of these services. So over permissioning when really somebody just needs read access to a specific service, giving them full create, delete, all those types of permissions on a service when they really don't need them. That's quite frequently called out by us as well. External exposures from infrastructure, as Mike mentioned, opening those RDP and SSH ports out to the internet, those are really common. It's not hard to restrict those to specific IP addresses. One of the things that I actually run into quite frequently in Azure is the Azure SQL databases are frequently locked down to pretty limited networks up front. And every once in a while, we'll run into an Azure SQL database that has all zeros, /24 for its available network. And it's basically publicly exposed out on the internet. So if we're able to get credentials at that point, then we can just log directly into the database, which can be kind of handy for us.
Yeah.
Cool. Next question, something that if you aren't aware of this, it can be quite painful if you experience it. Question is, don't the cloud providers fix issues automatically? Where does their responsibility end and yours pick up?
The old shared responsibility.
I think there's been some pretty big exploits.
Maybe, yeah. So, and God, it sounds like, kind of anything I can hear at, around 5, 6 o'clock, kind of every day. It's not my fault, right? Not my fault. I didn't do it. Right, I didn't do it. I'm not responsible or anything like that. And the reality is, and again, Amazon, Microsoft, all these guys have been Google. They've all been very, kind of clear about what their responsibility is to protect the, it's really security of the cloud versus security in the cloud, right? They're responsible for security of the cloud, the hypervisor layer, kind of the storage, making sure nobody walks into their data center and starts pulling racks, out of there or servers out of there to, compromise that environment. Anything that runs on their environment, that's your problem, right? So kind of the point is, and we hear this a lot, right? Oh, you have an open admin port, Amazon fixes that, right? Or and it's just like, oh, is that right? Well, not really. And that's kind of the point, is that you can use capabilities of the cloud providers to fix these things. Everybody can build a Lambda to shut down that open admin port. We'll just keep beating on that example. You can do that, right? And you can do a Lambda for every one of the things that are built as part of CIS benchmarks or any set of best practice that you want to implement, right? But how do you do it at scale? Because by the way, that Lambda that you just wrote, you got to copy it to every single account that you have. So if you've got 3 accounts, all right, I can do that. If you've got 3,000, that's a bit of a problem, right? So having a platform to do that, and by the way, what happens when you have the next issue of port 22? Right, and there's always going to be another one. So I mean, listen, we run into folks who can build it themselves all the time, and that's okay. If you can build it yourself, more power to you. I mean, that's great. You're helping the practice. But what we found is almost everybody else gets sick of either building it themselves or ultimately realizes that it's kind of outside of their capabilities, and that's when they're really looking for a platform, and that's what we do.
Great. Karl, anything you can help to avoid? I thought you got the ball. No, I thought you got the ball. How do you avoid that?
Well, I think the shared responsibility model and making sure that you review that for each of your cloud providers, understanding where that provider's responsibilities stop and where yours begin is really important. Really understanding what they will commit to in terms of fixing security issues for you versus what you have to take care of yourself. Since everybody's kind of homebound at the moment, I kind of liken it to an apartment building, right? You can rent out an apartment and get keys to the apartment, but if you leave the keys at the front door and somebody picks them up, opens up the door, that's kind of on you. That's not necessarily the landlord's fault, right? So making sure that you're securing things that you have permissions to or access to, and making sure that that's your responsibility, and identifying what the cloud provider's responsibility is.
Great.
Yeah, and,
Well, with that,
the other thing I would add. Oh, are we done? Oh, we're done.
We're close. If you want to jump
Okay.
in real quick.
Yeah, I just wanted to say that one of the things that folks do need to pay attention to is that your incident response motions absolutely change as you move into the cloud. So back to that shared responsibility model, you have to know where to get, kind of the logs that you need, right? Is it in CloudTrail? Is it, again, Security Center? What can I get? How do I use it? How do I escalate? Because if I do have a problem where I've got to shut down a bunch of accounts, you may not be able to do that because you've lost control of your, route. So it really changes a bunch of your operational motions. So you want to be considerate of that as well.
Excellent. Well, gentlemen, with that, let's wrap things up. Thank you for your excellent presentations and, of course, the questions from the audience and your responses. Just really quick, our two winners of the $50 gift cards are
Mike Rothman.
Stefan B, unless you've changed your name to Stefan, and Mario. I don't know. It might be Mario. That's close to Mike. Mario M. So congratulations to our winners. The DevOps.com folks will be reaching out to you to get you those gift cards. So join me in thanking two great speakers. Just great to listen to you both and share your experience with us. Karl Fosaaen, who's practice director with NetSPI, and Mike Rothman, president with DisruptOps. Especially thank you to you and everyone. We may all be locked in at home, but your time's still extremely valuable, and we're very honored you'd spend an hour of it with us. Thank you. Be safe, be well, and be careful out there.
Thanks, everyone.